All right, this lesson is about the division property of exponents. So it's about simplifying powers involving division. So if you're dividing powers and they have the same base, so again, the a here is the base, the m and n are the exponents, you can simplify these by subtracting the exponents. So 2 to the 6th divided by 2 to the 2nd can be simplified to 2 to the 4th. X to the 4th divided by x to the 7th, 4 minus 7 gives you negative 3, but don't leave your answer with a negative exponent. So hopefully you've learned about negative exponents. If not, I'll put a link up here. So then to make that a positive exponent, just put it under 1. And so let me show you real quick why this works, because this isn't just some magical thing. So let's expand 2 to the 6th. So that would be 6 2's being multiplied together. 4, 5, 6. And then in the denominator, I have 2 2's being multiplied together. Well, these 2's in the bottom will cancel out the 2's in the top, because 2 over 2 is 1. 2 over 2 is 1. And what you're left with is 2 to the 4th. So that's why you can subtract them. We could do the same thing with this one. So with this one, think about this. The 4 x's in the top are going to cancel out 4 of the x's in the bottom, and you're going to be left with 3 x's in the bottom. And that's why it comes out to this, 1 over x to the 3rd. All right, so let's look at some examples of using this. So x to the 8th divided by x to the 3rd. You just have to subtract the exponents, and that simplifies the x to the 5th. What if there's multiple variables? Well, that's okay. Just to make it clear to you, this could be rewritten like this: m to the 2nd, m to the 5th, times n to the 4th, n to the 3rd. So sometimes students get confused when you've got the variables all together like this. And actually, they don't even have to be in the same order. So, I mean, you could see a problem where the m and the n were switched, and so they didn't line up nicely like they do here. But you can always change the order to make it line up nicely like this. So the m's, we subtract the exponents. So it's going to be 2 minus 5. And the n's are 4 minus 3. So we end up with m to the negative 3rd, n to the 1st, and we don't need to write that 1. Now don't leave your answer with the negative exponent. So remember, to change it into a positive exponent, move it down in the denominator. The n is fine, so we leave the n where it's at, and we just move the m to the 3rd into the denominator. All right, so let's look at this one. We have negative 3 minus 5 for the a's, and for the b's, we have 7 minus 2. So this becomes a to the negative 8th, b to the 5th. Again, don't leave the exponent negative, so move that down to the denominator. The b is fine, so leave it where it was. And there you go. So some students will ask, well, can I simplify this? And the answer is no, because they don't have the same base. So you can only use this if the base values are the same. All right, so let's look at one more of these. X to the 4th over x to the 4th. So that's 4 minus 4. The y's, I have negative 1 minus negative 5. And the z's, I have 8 minus 1. Remember, there's a 1 here that's not written. All right, so 4 minus 4, let me just go ahead and write this out. So that would be x to the 0th power, y to the 4th power, and z to the 7th power. Well, anything to the 0th power equals 1. And 1 times this is just going to be y to the 4th, z to the 7th. So essentially, this just goes away. And so your answer will be y to the 4th, z to the 7th. All right, so let's look at one other property here. So what if you have a fraction or a quotient raised to a power? So basically what you're going to do here is you're just going to distribute that exponent into the numerator and the denominator. Pretty simple. So here's an example. We've got 3 to the 5th, 5 to the 5th. So we distribute that in there. Now, some problems might have you go ahead and work this out and figure out what 3 to the 5th is and 5 to the 5th is. So if you did that, 3 to the 5th would be 243, and 5 to the 5th would be 3,125. All right. What if there's multiple things in here? Well, you're going to distribute this exponent into everything. And hopefully you've already learned about raising a power to a power, and you know that you multiply the exponents together. So the negative 3 comes into the 2, comes into the x. You multiply 6 times negative 3 to get negative 18. It comes into the y, multiply 4 times negative 3 and get y to the negative 12th. So I have lots of negative exponents. So to change from negative exponents to positive exponents, just flip them over. So the 2 and the x are going to go in the denominator, and the y is going to come up in the numerator. So the y comes up top, and the 2 and the x go into the bottom. And then you can go ahead and simplify 2 times 2 times 2, that's 8. So your final answer would be y to the 12th over 8 times x to the 18th. All right, one more. So same thing as the last one. I'm going to bring this negative 2 into everything. Again, the 5 and the b are not connected, so it's got to come into the 5 and into the b. So I would have a to the negative 2 over 5 to the negative 2, b to the negative 2. So again, move everything around to change it to positive exponents. So I'd have 5 squared times b squared over a squared, and 5 times 5 is 25. So I have 25b squared times a squared. Now, one other thing you can do, another way you could have done that, let me show you this real quick, is to change this exponent to a positive 2. I could have just flipped this whole fraction over, taken its reciprocal. So I could have rewritten this as 5b over a, so I'm flipping it over, and then that exponent becomes a positive 2. And then you can see that would lead me into 5 squared b squared over a squared, or 25b squared over a squared. Same thing we got here. All right. So just another way of doing it. I could have done the same thing with b. So I hope that was helpful. If so, give it a like and a subscribe. Feel free to leave me a comment. Until next time.